Okay, one of my students, Andrew, made that. Thank you, Andrew, for that wonderful intro. And now I'm going to get to today's lesson, which is on solving exponential and logarithmic equations. All right, chapter 7-5 in your book. And I've been doing this a few years, and I think I like leading with this. I've done a lot of these problems, and I've boiled it down to different kinds of strategies. I'm not saying these are the only three, but these are the three primary ones that I've come up against. Maybe we'll add to it if people come up with others or if I come up with another one. But right now I got kind of three different ways I look at logarithm problems. And I try to identify them. You know, which way am I going to solve it? And I finally came up with this list after my first year of teaching this, and my students were like, God, Mr. Flory, it would have been nice if you gave us that in the beginning. So anyway, now I'm giving it in the beginning. And here's the first one. You know, if I can get something into this form here, where it's log to base 4 of 2x equals a log to base 4 of 8, you know, it's in the same form on both sides. Which means, you know, if these two expressions are equivalent, then, you know, the only thing that's different about them is the 2x and the 8. Everything else is identical. It has the same base. There's nothing in front of the log. It's no exponents. Which means if these two expressions are equivalent, then 2x equals 8, and I can divide by 2 and solve for x, which gives me a quick, easy answer of x equals 4. So that's the first kind of problem that I look for, and if you get one that's set up like that, it's real nice, it's easy, quick, just like that. The second one is log to base 2 of x equals 4, and you know, with that one, you convert to exponent form and then solve it. You know, 2 to the 4th power equals x, and then solve from there. Okay, so if I convert to exponent form, I get 2, let me zoom in a second, write a little better, 2 is the base, 4 is the exponent, equals x. 2 to the 4th power, that's 16, so that would be your answer. And then this is the new kind for you guys. You know, and you get the variable in the exponent, and this is tougher. You know, but the nice thing about logarithms is I'm going to show you here that you can take the log of both sides. You know, that's part of the golden rule of algebra. What you do to one side of the equation, you do to the other. With that said, you can do anything you want to both sides of the equation. So I'm going to take the log of both sides, and when I do that, I get the log 4 to the x. I'm in base 10 because there's nothing written there, and the log of the other side is also, whoops, that's not supposed to be x, it's supposed to be 10, is also in base 10. All right, so I got the log of both sides. Now here's one of the nice things about the logarithms is, you know, there's that law of logarithms where the exponent can get moved into the front, and then it's magically connected by multiplication instead of by the exponent. Okay, so now I'm here, and what I'm going to do next is I need to get the x alone, which means I can divide both sides of this equation by the whole log to base 4. Or the log of 4 base 10, sorry. So x equals the log of 10 over the log of 4. And believe it or not, that's a calculator-ready answer, which means you punch it into your calculator, take the log of 10 equals, divided by log of 4 equals 1.66. And that's the answer. So that's how I do the last kind. You know, and you can see here's my directions over here written. How to do that, take the log of both sides, move the exponent in front of the log, and then solve would be the second part of the directions. Okay? We're going to do more of those today as well. So, moving on. And if you got questions on that, watch a few more, and then if you still have questions, write them down, bring them to class. Okay, number 1. $16. I feel like this got changed. 16 to the 3x equals 8. Okay, and I'm going to solve this. Oh, this is actually the other way you could do it. It's change of base type of problem. So maybe I should make that actually. Let's do that. This. That should be strategy 4. I knew there was a fourth one. Change of base. So they are the same. And solve. Good, I can make this even better. Okay, so I look at this and and I'm going, gosh, 16 is a power of 2, 8 is a power of 2, and I can switch this around. 16 is 2 times 2 times 2 times 2, 4 times. 8 is 2 times 2, parentheses there, 2 times 2, 3 times. Which means now I can multiply those exponents together. 4 times 3x is 12x equals 2 to the third. Now, if these two expressions are equivalent, then 12x equals 3. There's just no other way around that. 12x equals 3, and then I can solve for x, which is going to be a decimal or a fraction. If I divide by 12, I can do the reducing in my head. 3 divided by 12 is 1/4 or 0.25, and that's the answer. So that would be the fourth strategy. All right. So maybe you should try one of these. Number, let's say that number was. So that was the 4 strategies. Put a line, problem 1. All right, 27 to the negative 3x equals 81. So why don't you try that? You can hit pause, and then I'm coming back, show you how to do it. I'm not hitting pause. All right, so 27 to the negative 3x. Those are both powers of 3. 3 times 3 times 3 is 27. So that's 3 to the third. 81 is 9 times 9, and 3 times 3 is 9, so that makes 4 3s is 81. And I don't need the parentheses there. So if I multiply these exponents together, my 3 and the negative 3x together, I get negative 9x. So I got 3 to the negative 9x equals 3 to the fourth. Okay, now if these two expressions are equal, then negative 9x has to equal 4 because everything else is all the same. Negative 9x equals 4. I can drop the bases, divide by what's in front of the variable, and get my answer. X, make sure it's negative, equals negative 4/9. And that's my answer. Okay. Number 2. Fifteen to the 3x equals 285. All right, so this one, be nice if that was a change of base. Unfortunately, I checked quickly, and 285 is not a power of 15. I'm kind of out of luck there. So what I'm going to do is I'm going to go one of the other strategies. The other strategy I'm going to take is I see that the variable is in the exponent, which makes it harder. So I'm going to take the log of both sides. And move that 3x to the front. Over there, 3x, and the rest of it stays the same. Log of 15, and over here is the log of 285. Now I want to get the x alone, so I'm going to divide both sides by the log of 15. And I get 3x equals the log of 285 divided by the log of 15. Looks crazy, I know, but it's actually Easy to punch it in your calculator. My last step here is divide by 3. So I want to get x alone, so I got x equals. So if you take a fraction, you divide it by a number, I can just move that 3 into the denominator, the log of 15 there. All right. When you punch it in your calculator, you're going to want to use parentheses around that denominator. Otherwise, it very well likely might, I'm not sure if it'll divide by 3 and then multiply the whole thing by 15. Anyway, if you use parentheses, it should come out correct, which would give you x equals 0.696. Now, if you didn't like it that way, you could, this is just more calculator kind of stuff, you could have gone here and taken this whole thing, punched it in your calculator, and I gotten a 3x. If I go 285 divided by log of 15, you get 2.087. 2.087. And then divide by 3. And you still get the same answer, 0.696. Okay? All right, so that's that one. Number 2. All right, so I'm on number 3. Number 3 is this: log base 4 of 4x minus 3 equals 2. All right, so this one, a little different. I'm not going to take the log of both sides. You take the log of the log. I don't even know what that would be. That'd be very complicated. So instead, I have the log of one side. I can switch this into exponent form. You know, that's always a nice strategy. 4 to the second power equals that, 4x minus 3. This is actually going to be real simple, real fast now. 4x minus 3 equals 16. I can add 3 to both sides and get 19. 19 equals 4x, and whoa, I think I made a mistake here. Oh, no, you can do that. Okay. Divide by 4, and I get x equals 19 over 4, or whatever the decimal version is of that. Okay. 4. Log of 3 minus 2x equals negative 1. Okay, this one's similar. I've already got the log only on one side, so if I switch it over to exponent form, you got to remember that when there's no base there, there's an implied 10. Which means this is the base, this number over here is the exponent, and this one here is the answer, 3 minus 2x. Okay, so 10 to the negative first power, that's the same as 1 over 10. 1 over 10 to the first, remembering you make your exponents positive by moving it to the other part of the fraction, which is really 1 divided by 10, which is, I'm going to use a decimal here, this is easy, 0.1. You could have got that by punching in your calculator also, 10 to the negative first power. So now I'm here, I got 3 minus 2x equals 0.1. This is just a linear equation to solve. So if I subtract 3 from both sides, I get negative 2.9 equals negative 2x. My last step is divide by negative 2. And I got x equals 1.45. And that's the answer. Okay? Questions? If you got questions, write them down, bring them to class. 6 or 5, actually. Log of 6 minus the log of 3x equals negative 2. All right, this one. A little different. Now, you guys learned on the laws of properties of logarithms that when you have subtraction between two logs like that, that I can combine them together. And it's really division with the numbers in the front being the 6, I guess that's actually in the back, 6 over 3x. Okay, so I'm going to combine those two to make one logarithm, and it equals negative 2. All right, now I'm in pretty good shape because now I can take it and switch it over to exponent form and solve it. Remembering that, this has a base, there's none written there. So there's an implied 10. So this is 10 to the negative 2 power equals 6 over 3x. And now I can solve that. It's not pretty, but it's a very solvable equation. So this is 6 divided by 3x. The opposite of dividing by 3x is multiplying by 3x. 10 to the negative second power is, write that on the side, 10 to the negative second is 1 over 10 to the second, which is 1 over 100, which is 0.01. And if I take 0.01 times 3x, I get 0.03x equals 6. And next I'm going to divide by 0.03, and 6 divided by 0.03 is 200. And that's the answer. Okay, that's the end of 5. I got one more here. Why don't we do this one like no, I'm not gonna give it a try, sorry. Because it's got something different I haven't shown you yet. 2 log of x equals the log, plus, not equals, log of 4 equals 3. All right, so I'd like to combine those together and make one log, okay? Now I can't just go and do that yet because I've got that 2 in the front, and that is not matching. Otherwise, maybe I could do it. But I can move it into the exponent form. So if I go log of x to the second power plus the log of 4 equals 3, now I can combine these two together. Remembering that, from your properties of logarithms, that when there's addition in between the two logs like that, that's really multiplication between the x squared and the 4. So this is log of 4 times x squared equals 3. Okay. Okay, so now I'm going to put it into exponent form. There's a base of 10 there. There's nothing written. 10 to the third power equals 4x squared. And this isn't so bad. 10 to the third power, that's 1,000. Equals 4x squared. Divide by 4. And I get x squared equals 1,000 divided by 4 is 250. Which means I take the square root of both sides. Plus or minus the square root of 250. And remembering to reduce radicals, I can go 25 times 10 is 250. Therefore, x will equal plus or minus square root of 25 is 5 root 10. And those are my answers. All right, so that was is that my last one? Nope, sorry. Okay, next. Number 7. I got 2 more and then I'm done. log of x minus 3 plus the log of x equals 1. Okay, so I'm going to combine those together. Remembering I got plus between the two logs, which means it's really multiplying what comes after the log. It gives me log of x times x minus 3 equals 1. Okay, now I can do distributive property there and get log of x squared minus 3x equals 1. And that should be in parentheses, because otherwise it looks like you're just taking the log of 3x of x squared and not the log of negative 3x. Okay, so parentheses and I'm good. Now I can switch it into exponent form. This has a base of 10 because there's always a base of 10 implied there, which means I go 10 to the first power, which is just 10, equals x squared minus 3x. And next, this is a quadratic equation. I see x squareds, I see x's and numbers, bring everything to one side, and then figure out whether you want to solve it by factoring or quadratic formula. I'm looking at that. I'm thinking factoring every day of the week because it looks easy. There's only two things that multiply to negative 10. That's 5 and 2 and 10 and 1. And 5 and 2, if I subtract them, will get me to negative 3 if I make the 5 negative. So I got minus 5 and plus 2. That way they multiply to negative 10 and add up to negative 3. Which means I got two answers, x minus 5 equals 0 or x plus 2 equals 0. Therefore, if I add 5 both sides here, I get x equals 5. And if I subtract 2, I get x equals negative 2. And those are my two answers. All right, last problem. Question number 8. Do a you try, see if you can do this. Log of 4x minus 3 equals 2. And notice how that minus 3 is not in parentheses. Not necessarily the same as the last one. Alright, so you should hit pause, try it out, and then see if you figure it out. I'm just going to work right through it. And I get, with this one, I'm going to get the log alone. I want to get rid of that minus 3, which means I get the log of 4x equals 5. Now I'm going to switch to exponent form. There's an implied 10 there, which means 10 to the 5th power equals 4x. 10 to the 5th power is a 1 followed by 5 zeros. 2, 3, 4, 5. And when I divide by 4, I get x equals 25,000. And that's the answer. Okay. All right, so if you have questions on that, please write them down, bring them to class. And I look forward to seeing you all soon, hopefully tomorrow. All right, take care. Thank you. Bye-bye.